Hey everyone, Mr. Newman here, and we're going to learn about 4.3 right triangle trig. So if I give you a triangle, you should be able to find the trig from given the sides. So you notice real quick what I'm doing is I'm writing my reciprocal rainbow up here just to make sure I've got the reciprocals correct. I even made it rainbow, Roy, G, Biv, yay. Alright, so the other thing I might write is Sohcahtoa, and you guys know where that comes from. And I want you to draw your attention over here to the triangle on the right. Notice that where, excuse me, where theta is, that changes what is the opposite leg and the adjacent leg. So, if, for example, if I were to have, let's say phi up here is another name for an angle we sometimes use, all of a sudden that changes what opposite phi is, that's on the bottom, and adjacent to phi, meaning next to, is right there. The hypotenuse is always the longest side, so you don't have to worry about that changing, but we do need to care about where our angle we're talking about is, because that changes what the opposite side and the adjacent side are. All right, let's use Sohcahtoa. So sine opposite hypotenuse. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And I'm just going to go ahead and fill all the rest of these out. Notice cotangent is the reciprocal of tangent, so I just flipped those. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So let's use this. Well, first off, I'm given a triangle. I need to know what all the sides are. Sometimes I only have two, so I need to use the Pythagorean Theorem to find the third side, and we get that c is the square root of 52. But, caution, if you can simplify square roots, you need to do that because that will change, especially these fractions later on. You'll see that in a moment here. So, square root of 52 is equal to 2 root 13. Ask a classmate when you get to class if you're not sure why that is. And this is an important point. Notice my triangle right now, I have not labeled an angle. You'll never see this kind of triangle on a quiz or a test. You always need to have the angle labeled. So we'll go ahead and pick this one, but if I chose the other one, that would change a lot of the answers. In fact, if you think about it, it would switch sine and cosine, because that's where opposite and adjacent switch. And because sine and cosine are switched, secant and cosecant would also be switched. And in fact, tangent and cotangent would also be switched. So that is why we call them coangles, because you notice up here where I've got theta and then phi, sine of theta is cosine of phi. Tangent of phi is cotangent of theta. So if you switch the angle, it switches each of the co-functions. All right, so moving on, since we picked that, I know that opposite is 6, hypotenuse is 2 root 13. I'm not writing that in equal to sine because I need to simplify it. My first step of simplifying is going to be 3 over root 13. And then I also need to get the root out of the denominator, so there's my answer, 3 root 13 over 13. For cosine, here we're going to simplify this as well, and you end up getting 2 root 13 over 13. Tangent also needs to be simplified, so we have 3 over 2. Now the last 3 we can just reciprocate, and notice I'm being careful about which ones I choose to reciprocate. So we have root 13 over 2, and then root 13 over 3. Notice how I chose this one right here to reciprocate. That way it made my life easier. Alright, so those are all 6 trig functions for this triangle. Let's do another kind of problem, is if I ask you to find all 6 trig functions for a triangle where you know what one of the trig functions is equal to. The nice thing about a triangle, unlike our unit circle, is that if I say it's a triangle, all the angles have to be, all the sides have to be positive, which means all the trig functions are positive. That is not true when the angle is greater than 90 degrees or greater than pi over 2, but, or less than 0. But in this situation, they'll all be positive. So first thing I'm going to do is I'm going to draw a triangle where this is true. Tangent of theta is equal to 3 over 4. Well, the nice thing is that I can pick any triangle I want. Because the ratio of sides doesn't matter, you're going to see that if you make the triangle larger or smaller, as long as that ratio is the same, that's all that matters, and all 6 trig functions will be the same. So I'm going to pick, let's make, I know tangent TOA is opposite over adjacent, so let's make the opposite 3 and the adjacent 4. That means that when I've done the Pythagorean Theorem, my long side is 5, so 3 squared plus 4 squared equals c squared. Solve that. And I want you right now to answer all of these. I'll take care of the tangent, and you guys answer the rest. Great. Now we're on to application problems. So let's say you want to find the height of a flagpole if the shadow is 15 feet long. Well, here's my flagpole. There's my American flag. You can count the stripes if you want. And standing at the end of the shadow, looking up, you have an angle of elevation of 40 degrees. Well, angle of elevation, that means how high up you're looking at, starting from the ground. So that angle right there is our angle of elevation. So notice 40 degrees here. That is a right angle. And I'm looking for the height, x. So tangent of 40, I'm going to choose the tangent function because tangent is opposite over adjacent. So TOA, tangent of 40 degrees is x over 15. Multiply both sides by 15, you get this. And notice, you can type this in a calculator, or you'll be required to type it in a calculator. Notice that I have degrees, so my calculator needs to be set in degree mode. So make sure you check with your classmates in class as well about how to do that. Now, I got 12.54 when I typed it in, and I'm looking at this going, wait a second. It looks from my triangle like x should be bigger than 15. Well, my mistake was this 40 right here, that is not a 40 degrees angle. And it's always a good idea to draw your angles to scale, so that way you can check afterwards. So let me fix that real quick. Let's see here. Now that looks a little bit more like a 40 degree angle. Because I know that 40 is less than 45, so it's going to be smaller than a 45 degree angle. So there's my 40 degree angle, and now that answer looks a lot better. All right, let's do one more problem here. A skateboard ramp is 4 feet high and has an angle of inclination of 18.4. How long is the ramp? Well, here's my skateboard ramp. That's 4 feet tall right there. The skateboard, my totally rad skateboard, is going down the ramp. There's my angle of inclination. So this is similar to an angle of elevation. It's how high the ramp is starting from ground level. And there's what we're looking for, x. How long is this ramp? So we set up sine because sine is opposite over hypotenuse, and those are the two values that I have and want to find. And we've got a problem here. X is in the denominator. If x is in the denominator, I've got to multiply by x to get it out of the denominator. Don't be one of those people who multiplies by 4 expecting the 4's to magically disappear. No, we need to multiply by x. And once we've done that, then we can divide by sine of 18.4. Once we've done that, we can type that in the calculator, and that right there is what I want you to type and come to class with your answer. Thank you very much for watching.